All right, here we are. Welcome back. Today we're going to go through section 651, which is solving radical equations. So up till now we've been simplifying expressions. We haven't actually solved an equation. That's what we're going to get into today. So if we jump right in, our EQ is how can I solve equations containing square roots and other radicals. As a quick little warm-up, just to kind of remember how we simplify these things. If I've got a power of 3/2 that's being applied to an expression like 9x to the fourth and y to the negative sixth, I'm going to split this up because that exponent is being applied to all three parts. So I've got 9 to the 3/2, x to the fourth to the 3/2, and then y to the negative 6 to the 3/2. So in order to do this, 9 to the 3/2 I can just type into the calculator. But remember, a denominator of 2 basically means the square root. So what this is saying is I'm going to square root 9 and then raise it to the third power is basically what that's telling us to do. Again, feel free to type in the calculator. Remember, most calculators are going to require you to put parentheses around that if you type it in. So for instance, not on this, on here, on the calculator, we've got 9 to the power of 3/2, and that should give us 27. Okay, so this is 27. We know if an exponent is being raised to another power, I'm going to multiply those together. So 4 times 3/2 is going to give me x to the, whoopsies, that's going to be x to the 6th. And then if I do the same thing, negative 6 times 3/2, again, just typing in the calculator, that'll give me y to the negative 9th. Then, of course, a negative exponent can't be part of our final answer. So we're going to put this over 1, and we're going to take that y and move it to the bottom. So our simplified answer is going to be 27x to the 6th over y to the 9th. Okay, so again, just some of the things that we can do to simplify these expressions. But what we're going to do today is actually apply it to an equation. The homework from yesterday was 12 to 66 every third problem. This was from section 6.4. So make sure you're asking those questions if you've got them at all. Okay, so we know that a square root is used to solve a squared equation. So for instance, if I said what number squared equals 16, we know that we can square root both sides to undo the square root and the square, canceling each other out and just getting x equals. And then we learned that if you're square rooting, you need the plus and minus. So we say x is plus and minus 4. That was back in chapter 4 that we talked about how to solve those equations. So now the opposite's true. If I have the square root of x equals 9, most of us would know that I can just plug in 81, right? I know the square root of 81 is equal to 9, so then x must be 81. But if I didn't know that off the top of my head, in order to cancel out a square root or to get rid of a square root, I'm going to square this, and I can do that as long as I square both sides of the equation. Here I end up with the square root canceling the power, x equals 81. Okay. If you have something like this where it's x plus 12 to the 1/2, again, remember that the 1/2 power is the exact same thing as the square root. So if you would like to rewrite the equation like that, it's totally fine. It's the exact same thing. Again, I'm going to then take this and square both sides of the equation. If I square both sides, I have, on the left, it's just x plus 12. Square 7, that gives me 49. We haven't completely solved the equation yet because we want to isolate or figure out that unknown value of x. So I'm just going to take away 12 from both sides, and we get a solution of x is equal to 37. Remember, solving an equation is always, you can always check your work. If I go through and take 37 and plug it back in here, if I do 37 plus 12 and raise that to the 1/2 power, that's 49. 49 to the 1/2 is the square root of 49. So that gives me 7. So I can check my work very quickly to know that I did it correctly. Finally, if we have a third root, so if I've got a radical to the third root, just like to get rid of a square root, I squared both sides. To get rid of a third root, I can raise both sides to the third power. Before I do that, though, if there's anything going on, any stuff outside the third root, as in this case, we have the -5, I have to get rid of that first. So I'm going to start by adding 5 to both sides of the equation, right? If you look at the previous example, I waited to subtract the 12 until after I squared both sides, and that's because the 12 was in the parentheses or underneath the square root. Here, that -5 is not, so I'm going to add 5 to both sides. That gives me the third root of x is equal to 8. And then I'm going to go ahead and raise both sides to the third power. So I raise this to the third, I raise that to the third. I get just x on the left side, and 8 to the third power is 512. We double check here. Okay, so that gives me x is equal to 512. Okay, so we can use exponents on both sides of an equation if our equation contains radicals. And that's kind of the basic way to solve equations that have radicals in it. Go ahead and pause here if you want to give those two a shot. I'm going to jump in right away to doing this. Here, since the 3 is outside the radical, I need to get rid of it first. One common mistake that students make is thinking they can distribute. As we know, I can't multiply a number or a coefficient like 3 with a variable if one of them is underneath the square root and the other one's not. So instead, I have to use division here. So I'm going to divide the left side by 3 and the right side by 3. There, my 3's will cancel, and I get the square root of x minus 4 is equal to 5. Now, again, I have to decide, am I going to add 4 or am I going to square first? Because the square root contains the -4, I can't get rid of the 4 until the radical sign is gone. So I'm going to raise both sides here to the second power. So square this and square this. And that gives me x minus 4 is equal to 25. Okay. And then, of course, we can just add 4 to both sides. And I get the missing value of x is 29. Again, feel free to go back and check. If I were to take, let's check this real quick just to make sure. It was 3 times the square root of x minus 4. And that was supposed to be equal to 15. Okay. 3 times the square root, well, 29 minus 4 is 25. Sure enough, 3 times 5 is equal to 15. So we know our answer is good there. Okay. Again, like, is the checking of the work strictly necessary? No, but if you're someone who likes to ask a teacher or a classmate, like, hey, did I do this right? This is a real quick and easy way for you to check and see if you did it. Here, I have the 3 out front. Now notice that's not a multiplication by 3. That's 3 being added. So I'm going to go ahead and subtract that from both sides to begin. When I do that, then that cancels, and I have 7x plus 1 to the 1/3 power equals 4. I hopefully recognize that the 1/3 power is the same as the third root after what we discussed yesterday. So you can rewrite it like this. No matter which way you write here, whether you have it to the 1/3 power or the third root, regardless, I'm going to raise both sides to the third power. Okay. And what that's going to do here is the third root and the third power will cancel, and I get 7x plus 1 equals 4 to the third power, which is 64. And now we're going to go ahead and finish this out using our standard algebra practices. So we take away 1 from both sides. I get 7x equals 63. And then we're going to divide both sides by 7, and x is 9. Okay. Again, at this point, you can feel free to go back and check. We can plug in the 9 in for x in the original equation and double check to make sure we get 7 on the other side. So if you've got a radical, the big thing, if you have a radical in your equation, make sure you get rid of any addition or subtraction or multiplication, whatever, outside the radical before you actually start squaring or cubing or whatever you need to do. Okay. This is where we get to kind of the meaty, good math. And what happens if I have an exponent, but that exponent's a fraction? So if I look at something like this, where it's x to the 5/4 minus 1 equals 242, either way, I know I'm going to have to add 1 to start with. So I get x to the 5/4 equals 243. Now, I could rewrite this. Okay, I could rewrite this into a radical and say this is the 4th root of x to the 5th equals 243. I could then raise both sides to the 4th power because I know that's what will get rid of the, okay, I can raise both sides to the 4th because I know that's what will get rid of the radical on the left side. So I get x to the 5th equals some gigantic number, 243 to the 4th power. Oh boy, what's that? 3,486,784,401. I then know I'm going to get rid of the 5th power. I need to 5th root this, and I can do that to both sides. So then in the calculator, I'm going to do 5 math 5 of 3, 4, 8, 6, 7, 8, 4, 4, 0, 1, and I get perfect. X equals 81. Okay, so here we've got a solution of x is equal to 81. Okay, so that's something that that's one way to do this problem. As you can tell, it's kind of crazy, and it ends up being, you have to deal with numbers that are way too out of control. So we do have a simpler way to do this problem, and I wanted to show you that at least, just so we have that in our back pocket. But if you have an equation that contains an exponent that's a fraction, the easiest way to cancel the 5/4 power, and you actually learn to do this back in intermediate algebra, is I'm going to use the reciprocal. Okay, I'm going to use the flipped version of that same fraction. So I'm going to actually raise both sides of this to the 4/5 power. Okay, and the reason that I'm choosing the 4/5 power is right here is where the magic happens. If I multiply 5/4 with 4/5, that's going to end up being 20 over 20, which is just equal to 1. So when I multiply reciprocals together, they end up, well, they will always equal to just 1, which means I don't have an exponent anymore for my variable. So now all I have to do is take 243 and raise it to the 4/5. Again, that's something that I can just do, 243 exponent of 4/5, right? And I get my same answer of 81. So if you want to solve it, this other way, x equals 81. If you feel like solving it this longer way, where you want to rewrite it as a radical, whoopsies, you can certainly do that, and that's a totally reasonable way to do it. But I think this is a lot quicker. So if an equation contains a rational exponent, use the reciprocal power, to solve. Okay. So in a problem like this, negative 2x to the 2/3, this one can be a little tricky. Since we don't see parentheses at all in the problem, this 2/3 power is only applying to the x and not to the 2. So that means I need to get rid of the negative 2 first before I do anything. So I'm going to go ahead and divide by negative 2. to get rid of that. Okay, so I have x to the 2/3 power is equal to 64. So to get rid of the 2/3 power, I'm going to raise both sides to the 3/2. Pretty straightforward again, just using the reciprocal. Okay, to the 3/2. So the powers on the left side will cancel each other out, and I've got x equals. Now this is where we have to be careful. If you think about what the 3/2 power is doing, right, just on the side here, if we think about this is asking you to take the square root of 64 and then raise it to the 3rd power, okay? And that's fine. That's something that works out nicely. But what we need to be careful of is, just like we talked about earlier, if you are solving an equation and you choose to square root both sides to solve it, you need to introduce positive and negative, okay? So in this situation, because we are solving an equation, the square root of 64, because I'm square rooting both sides, I have to write as positive and negative 8, both. So I'm going to end up with 2 solutions for this. So when I type 64 to the 3/2 in the calculator, it's not going to give me plus or minus. It's only going to give me the positive version, 64 to the 3/2. Okay. But I need to be aware that this is a situation where I need to do both plus and minus. So if I come back here, x is equal to both positive 512 and negative 512. And I can go ahead and just leave it like that. Okay. This is kind of like the absolute value stuff that we worked with. It's very specific, and in a certain situation is when you have to use it. So we're going to, on the next slide, we're going to talk about when do we have to use it and how do I know when to bring the plus minus in. But just understand that that's where it's coming from, because we are square rooting 64. We know there's actually 2 square roots of 64. It's both positive 8 and negative 8. So if you are raising both sides of an equation to a fractional power, okay, so if what you are doing to both sides is a fraction, if the power you are raising both sides to is, if the denominator specifically, if the denominator is odd, then there is only going to be one solution, okay? So for instance, if you're raising both sides, let's just give an example real quick. If I have x to the 3/2 is equal to 8, okay? If this is an equation I'm presented with, in order to solve this, I need to raise both sides to the 2/3 power, okay? Because I'm raising to the 2/3 and the denominator is 3, which is odd, I do not have to worry about plus and minus. So I type this in the calculator and I should get x equals 4. That is my only solution there. On the flip side, if your denominator is even, and again, not in the original problem, if the denominator that you are raising both sides to, so if you are doing a power that's got an even in the denominator, then there are going to be 2 solutions, and that's where you need to use plus and minus. So again, an example could be x to the x to the 4/5, okay, is equal to, let's say, 16. Okay. To then solve to get x by itself, I would use the reciprocal power, which is 5/4. But because I am raising both sides to the 5/4 power, when I plug 16 to the 5/4 into the calculator and I get 32, I need to put both positive and negative 32 in there. Okay. So that has 2 solutions, whereas our previous example only has 1. This is something that we'll be talking about constantly, and like, be careful. Do you need plus minus? Do you not? And why? But just be aware that that's kind of the one big difference in this section is sometimes we'll have one equation or one solution, sometimes we'll have 2. So let's take a look at what this looks like. If I have the equation 2x plus 1 to the 2/3 equals 4. The first thing you should identify is is there anything outside the parentheses on the same side of the equal sign? So if I just kind of look at the left side of the the left side of the equation here, I have a 2 and a 1, but it's all in the parentheses. So I'm going to start by getting rid of the 2/3 power. So I'm going to raise both sides to the 3/2. If I do it to one side, I got to do it to the other side. Doing that will effectively cancel out those exponents and leave me with 2x plus 1 is equal to, now here's where if I type 4 to the 3/2 power, 4 to the 3/2, the calculator is going to tell me 8. And then I have to ask myself, do I need to introduce plus and minus? Because this is basically telling you to square root 4 and then raise it to the 3rd power. And since I'm square rooting 4, I do need to include the plus and minus. So now I'm going to have two solutions. One where 2x plus 1 equals positive 8, and one where it's equal to negative 8. So from here, I'm going to split it up into two equations. So 2x plus 1 equals positive 8, and 2x plus 1 equals negative 8. Then we can just use regular algebra. Subtract 1 from both sides. 2x is equal to 7. So one of my solutions when I divide by 2 is 7/2 or 3.5. Okay. My other solution here, again, the steps are going to be the same. Be careful when you subtract 1 from negative 8. That's going to give me negative 9. And then I divide by 2 on both sides. And that is x is equal to negative 9/2 or negative 4.5. Okay. So because we raised both sides to the 3/2 power, we need plus minus. And so it gives us two solutions. The rest of the steps are the same. It's just knowing when to do that and when not. This is just a step-by-step breakdown of that previous problem. If you want to take a look at it or write it down this way, essentially, again, just redoing the same thing, but with an explanation of why we're doing what we're doing. So go ahead and pause this, see if you can give this problem a shot. Note that there is stuff outside the parentheses, so we're going to have to deal with that first. Specifically, I'm going to add the 2 first, because when we're dealing with algebra, we want to do any adding or subtracting. We're basically going in reverse of PEMDAS. So I want to add or subtract before I multiply or divide. So I'm going to add 2 to both sides. There's 81. Now we're going to divide by 3. Because again, I can't distribute because there's that exponent there. So I have no other option but to divide by 3. So here I get x minus 5 to the 3/4 is equal to 27. Now I'm ready at this point to get rid of the exponent. To get rid of the 3/4, I'm going to raise to the 4/3 both sides. If I go to the calculator and type 27 to the 4/3 power, I will get 81, which is kind of weird because that's what we started with. And the question is, do I need plus or minus here? This is telling me to third root 27, and since I'm third rooting, that is only one number. I don't have to worry about doing the plus minus. So this is my only solution, or this is going to be my only equation I have to solve. So we finish up, we add 5 to both sides, we get x equals 86. Okay. So basically, again, just like it's just the algebra we already know how to do. We're just adding in this, if you have a fractional exponent, flip the fraction and apply that to both sides. The last thing I want to look at is what happens if something is in radical form. You could absolutely solve this equation as it stands without changing the form of it. But now that we know the reciprocal rule with the exponents, what I'm going to do is I'm going to rewrite this. I'm going to rewrite this as 2x plus 1 to the power of, dramatic pause, 3/5. Okay. There, that exponent of 3 is my numerator, but the index is going to become my denominator. So those things pair together to get 3/5 for my power. I'm going to finish off copying down the equation. So plus 1 equals 25. And now we're going to solve it exactly like we just did on the previous slide. So I'm going to take away 1. My next step is going to be to divide by 3. 2x plus 1 to the 3/5 equals 24. I see that pesky 3 out front, so I'm going to divide there. Okay. Get each step in a different color. So I got 2x plus 1 to the 3/5 is equal to 8. Now if I raise both sides to the reciprocal power, right, because the 2x plus 1 is in parentheses, so I know now it's time to raise both sides to the 5/3. Okay. If I do that, 8 to the 5/3 power, that's going to give me 32. Do I need plus minus with the 32? I don't, because again, I'm dealing with the third root there. My exponents cancel on the left side, so I'm just left with 2x plus 1. I'm then going to finish this off by doing just straight algebra. 2x equals 31. Divide both sides by 2, and I get an end solution of 31/2 or 15.5, however you want to think about it. Okay. So the big thing there is if it is a radical, sometimes it's going to be easier to just to change it to an exponent. If you didn't change it to an exponent, you would have to third root both sides first, and then raise both sides to the 5th power to get rid of the radical. But I think if you rewrite it as an exponent of 3/5, then we can do both of those things in one step. So the homework for 651 is from 9 to 33 every third. I missed the summary, so let's do that real quick. Forgot that slide. Our EQ was, how can I solve equations containing square roots and other radicals? I think this can be summed up pretty succinctly as just to say, if an equation contains a fractional exponent or contains a fraction exponent, then we are going to use the reciprocal power. And that's, again, oversimplified, but that's probably the big thing from the lesson that is what makes this new compared to previous learning. So homework again, 9 to 33 every third, and we'll talk again soon.